recent related works. And if you comment the advantage and disadvantage of related papers, and compared to them, I think it will be better if you more clearly focus on your advantage and features of your method. Actually, you already showed us the features and advantages of your work, but it cannot be clearly seen. So and also next comment is that in conclusion, it is better to explain about limitations or disadvantages of your method. So maybe your method is not expensive, right?
Yeah, right.
Then maybe some disadvantage or limitations will occur. Right? So may occur. I don't know, but but actually, in conclusion, you need to summarize your work, and then you need to explain limitations or disadvantages of your work, and finally, you need to comment about the next future work for improving your work. So in conclusion, these three things are not clear. So you need to clearly mention about that. And I would like to see some table actually in your presentation. I didn't see the table. So table which contains numeric things should be given compared to other methods. So, but I haven't seen some tables in your presentation. Final performance of your method should be summarized in a table. That will be better.
Thank you.
So can you briefly describe about your method's limitation, or so can you describe it briefly?
I will do.
Okay. So is there any type of slide for that? No type of slide?
The best advantage in my research, it will be compared directly between the simulation and experiment data. The limitation of that method is developed for the simulation data. Actually, know that the atmospheric measurement is a challenge for any optical engineering and any researcher in that field. But also, the simulation will be finite. It's not easy. So this is the limitation. It's maybe almost no recommendation and no reference for make this kind of thing, this kind of interprogram. We cannot show too much in this study. So the optimization process and the calibration process is the new thing in that study. We have to two steps about the flash measurement first to fix that parameter. And it's the reason why in my slide I fixed that parameter. And it's a new method. But the limitation for the time in the defense, I cannot show very detailed about that. And if you can see more in here, so I think that's can understand.
Okay.
And about the, you can recommend about the compare between the other methods is our proposal. So I already included a little bit in the introduction. However, I think that is recommended the better the compare between that two. I focus on that measurement, and that study focus on the resolution of that method, and it is the thing we get in that study.
So do you have, where did you get that, span parameters? Did you create that, parameters, or when did you get those parameters?
Yes. So
From
the software.
Kim, or just,
The parameter is
Yeah.
this is the come from the fabrication group. It come from Kim, right? Yes.
Right.
If they provide a very high accuracy of the surface, so we follow in that to compare with our methods to apply the measurement.
And also you study the, convex, types of, lens experiment, right? Convex type.
You come back time
Yeah.
for the target.
Have you ever tried to, concave types of,
Yes.
really?
Yes.
Is it- What's the difference from the, concave types and convex types?
Yes.
This is, what's
Yeah.
the difference?
The most different in our project, we want to hit more just only one focusing lens to can measure the multiple target, not only the convex but also the concave. And the difference between that two you mentioned that it's just a distance between the focusing lens to the target. As I did write on this about the convex. So if here is the focal length, is the convex, and all of the beam will be reflected in that way. So it's about the concave. We have to more for the distance between that two. It is the way we have to get more the parameter for optimization process I mentioned in here.
Show us, next slide, maybe screen 2. Okay, yeah. Just, if we have a lot of, coefficient of, a spiral lens,
Yes.
the shape of, a spiral is very high, and
Yes.
so you have the slope is very, steepness, right?
Yeah.
Yeah, so I think that your system is, I don't know, what kind of, just walking distance or walking depth of focus. Can you, measure the steep slope?
You mentioned about the
Yeah.
focusing working distance for this kind of focusing lens. Right?
Yeah.
In our selection, we select this kind of. I did not including that information about the focusing lens in my PPT. So in my selection for the focusing lens is around the 18 nanometer. Working distance for the focal length, aspheric lens.
And also you have a lot of, just, coefficient of, errors.
Yes, right.
Yeah.
Yes,
So lens it's very difficult to, measure the, like this in, method. Is there any other problem to, if we have more coefficient of, spiral lens?
About this lens.
Yeah.
So this lens is designed by the commercial company. So they will provide for me about that coefficient. We just apply this one for that method. And the coefficient we will apply is the target parameter. So we will, because we not sure that the target is perfect or not, we have to change this value and we get the new value.
He did not ask that one. He's asking about, so you are currently optimized how many parameters? 5 parameters of the aspect parameters,
Yes.
right? However, he's asking about, what about increasing, I'm talking about, if the surface is very complex, there might be more coefficient on it, right?
Yes.
So in that case, your optimization process is going to be very complex.
Yeah.
So
It is
it's
separate, but
So I think you better explain about your experience on it.
yes.
Experience. I'm talking about what about the how many coefficients did you try?
Yes.
Maximum. How many parameters did you try?
Yes. about the aspirate, so the two parameters for define the target and focusing line in the P6 and P7 in the kit. So this configuration will be fixed using the flux. So we can add in more for the aspirate parameter like the conic, the second coefficient, and getting more for this. We can add in more for the two new parameter in here in the conic and the second coefficient of the aspirate, and adding more for the 10 or 12 and higher of the order aspirate coefficient. But if it's not needed and it is not too much change, so we don't have to add more for the higher. It takes too much time for the optimization process.
오래 걸리잖아. 저거 한번 오토마이즈 하는데 저희 뭐 한 아직까지는 좀 프로그래밍이 그 최적화가 안 돼 있어가지고 저 이거 한 번 재는데 한 번 빵 찍고 데이터 어드레스 쓰는 데가 10분 걸려요. 아직까지는 좀 계속 파라미터들을 바꿔가면서 실험 결과랑 시뮬레이션 결과랑 일치될 때까지 저걸 계속 바꿔요. 타겟 저 포지션들 계속 바꿔요. 그래가지고 저 값이 이제 우리 현재 지금 아는 서비스를 재고 있거든요. 알고 있는 서비스 저 값을 이제 찾아내는 건데, 네.
나중에 이제 실제로 이제 가공을
네.
한 데이터를 가지고서 이거 지금 실제 가공한 데이터를 가지고 한 거 아닌가?
요거는 가공을 이제 키면서 하긴 했는데,
네.
키면서 가공하시고 그다음에 저거를 폼테이스로 측정을 해서 저
프로파일
포지션을 받은 거예요.
네.
그다음에 그 타겟이랑 프로파일 저 포지션 받은 다음에 저 측정을 딱 해서 저 값이 나오는지 저희 계속 이제 하는 거죠.
10분 정도.
10분 정도 지금. 네. 그 다음에 이제 저희는 딱 측정 다 끝난 다음에 이제 저거 커미션을 이용해서 서비스를 만들어내는 게 저 밑에 거예요. 저 밑에 거. 이렇게 다 같이 돼 있는 볼록한 거. 그 다음에 저거랑 이제 저거가 정답이잖아요. 저희 옵티마이제이션한 우리의 답과 저 완전 차가 오른쪽, 오차 오른쪽이에요.
아, 신나고 메타.
네, 신나는
그게 수준 나오는 거 아니에요?
네, 신나는 지금 근데 이게 이제 항상 잘 나오는 건 아니고 제일 이제 잘 나오는 거 보여주고
원래는 베스트 샷을 하는 거니까.
근데 저게 이제 킹에서는 이제 사실 이거는 실제 이제 저게 광학 소리 값이에요. 진짜 잘 깎은 거예요. 저거 만든 장비 깎은 게 아니고 저거 미국 장비 남은 장비. 네, 그걸로 측정 거기 거의 비슷하게 나왔어요. 그러니까 이제 우리가 답은 알고 있으니까 잘 들어갈 수 있는데 실제로 이제 제이스프리시에서 만든 걸 깎으면 이제 저 광학 설계에서 나온 수치를 집어 넣어도 저 값이 안 나오죠. 이제 아무 답도 모르는 거죠. 근데 그런 상황에서 이제 잘 들어갈 거냐 이제 요거 이제
실제적으로는 좀 풀스택 장비 가지고서 먼저 이렇게 모든 걸 좀 옵티마이즈 하고 난 다음에 JS를 들어가야지. JS가 지금 장비도 약간의 지금 문제가 있는 것 같아요. JS가 네. 안 보여줬죠 장비. 실제로 지금 기계연에서
Let's go back to the last one.
네, 그 기계연에서
이 JS입니다.
네. 이 장비를 하는데 이 지축이 좀 문제가 있다고 그러더라고요. 그래가지고 실제로 저 정지용이가
정지영 씨.
그 친구가 가공을 했는데 안 나온다고 그러는데
계속 지금 저번에 저희 이거 설치할 때 이제 JS 사장님 오셔가지고
네.
사장님 원래 팀에서 일하셨다고요.
네, 선생님이 팀에서 박정원 박사님하고 있다가 그 다음에 세스코 갔다가 세스코에서 나와서 JS를 만들고 거기 이제 조이사도 거기 같이 이걸 되고
다 오셨어요 그때 장비.
그렇죠.
네,
세팅할 때다
하고.
나오죠.
그래가지고
근데 실제적으로 이거를 지금 가공할 때 그럼 이건 어떻게 해야 돼요?
이게 지금 위에 로터리 테이블.
네, 로터리 테이블이에요.
그래가지고
돌려서 뒤쪽으로 가 있고.
맞습니다. 돌려서 가공하고 툴이 있어서 가공 끝나면 다시 로터리 테이블 돌아와서 측정하고 이렇게 하려고
그렇게 하려고
하는데
하는데 이거 여기서 문제가 있을 것 같은데 테이블에서도 야 이게 정밀도가 안 나오면 이 수십만 원짜리가 이거 어떻게 레귤러지 나오지 이거?
그 정밀도라는 게
야, 이 장비가 돌아갔을 때 이거
아,
달라지잖아.
그거 그래서 그러니까 일단은 사람이 측정하는 사람이 붙어가지고 측정할 때마다 정렬을 해줘야 되는 것 같아요. 근데 저게 로테이블이